Hi guys, my name is Melissa, and in today's video we're going to be talking about factor blobs and pyramid descent. So these are related concepts, and so we're going to cover both concepts today. And because we have a lot of practice problems, I'll leave some practice problems so that you guys can solve them yourselves. But I'll still go over the solution quickly, but I'm not going to go over some practice problems in too much detail so that you guys also have an opportunity to kind of solve them yourselves. So we're first going to start by looking at factor blob puzzles. And so in a factor blob puzzle, we circle blobs of two or more factors whose product is a given target number. And so the rule is that every square in a blob must share at least one edge with another square in the blob, and blobs cannot overlap. And the goal is to use every number in the grid in one blob. And so, for example, I'll kind of go over an example problem so that we can kind of get a better understanding of what this puzzle looks like. And so our target number is 30, and since 6 times 5 is 30, the 6 in the top left corner must be paired with the 5 beneath it. And so that's one blob. And also similarly, to get 30, we need to pair 10 with 3, so these two are going to be one blob. And 2 and 15 is going to be one blob. And then these three can be one blob and grouped into one group to get the target number 30. And in some cases, it might be useful to find prime factorization of the target number and of the composite numbers in the grid. And so, for example, 2, 3, 5, this blob was a combination of prime numbers. And so for problem 89, we're going to solve this factor blob puzzle with a target number of 45. And so for problem 89, we're going to start by looking at the corners first. And so for 9, we know that 9 must be multiplied by 5 to get to 45. And so this is going to be one blob. And then looking at the top right corner, we know that 15 must be multiplied to 3 to get 45. So that's going to be one blob. And the same goes for the bottom right corner where we have a 3 and a 15 next to it. And then these three can be one blob because 5 times 3 times 3 is going to be 15 times 3, which is 45. And then for problem 90, we're going to look at the bigger numbers, especially because 28, our target number, is pretty small. And so we're first going to start by looking at 14, which is our largest number. And so 14 must be paired with 2 to get to target number 28. So these two are going to be one blob. And then we have 7 and 4 that must be grouped together. And so this 7 must also be multiplied or paired with the 4 to get to 28. But we don't have any 4s left, but instead what we do have is a large blob, and that's because 1 times 1 basically makes no difference, since it just gets the number itself, and 2 times 2 gives us 4, so this entire blob is equal to 7 times 4, which is 28. And then for problem 91, we're going to use prime factorization because the target number is really big. And so 750 can be expressed as a multiplication of 3 and 250. And 3 is a prime number itself, so we're just going to stop there. And then 250 can be further broken down into 50 and 5. 5 is a prime number, so we stop there. 50 can be further broken down into 10 times 5. 10 can be broken down into 5 times 2. And so the ones with the underlines are part of the prime factorization. And so we can write this as 750 equals 2 times 3 times 5 to the power of 3. And so for problem 91, we want to group 1, 2, 1, 3, and 5 3s into each number blob. And so we can group these two numbers together because 25 is basically 5 times 5, and 30 is 2 times 3 times 5. So in total, that gives us 2 times 3 times 5 to the power of 3. So those two multiplied will give us 750. And looking at this 3, we know that we need to put this 3 in a blob where there's a 1, 2, and 5 3s. And so 25 is 5 times 5. And so in this blob, we have 1, 2, 1, 3, and 3 5s. And so that's going to be one blob. And then the remaining numbers should be grouped into one blob. And so already we have 5, 5 times 3, and 5 times 2. So we have 2 times 3 times 5 to the power of 3. Now we're going to look at problem 92. And so for problem 92, we're going to learn that separate numbers that cannot be in the same blob with walls. So what this means is that, for example, for 63, we can do prime factorization into 3 to the power of 2 times 7. And then that means that we need 2 3s and 1 7 in one blob. And so we have 2 7s here. And that means that we cannot have 2 7s in the same blob because we only need 1 7. And so basically we're going to draw a wall around this 7 so that it separates it from the other 7s. So we're basically creating a wall. And also we cannot have more than 2 3s in one blob. So we're going to separate the 9s by creating a wall because 9 is 3 times 3, so just the 9 itself fulfills the 3 to the power of 2 requirement. And then we're going to group the remaining numbers into blobs, and so we're going to do 3 times 7 times 3 because that's 1 7 and 2 3s. That's also 1 7 2 3s, 1 7 2 3s, and 21 is 3 times 7. And so that's going to be 1 7 and 2 3s. Now we have some more factor blob puzzles. And so I want you guys to solve problem 93 on your own because we have a lot of more difficult factor blob puzzles, as you can see with the stars. And so I want to assign problem 93 and 94 to you guys so that you guys can try solving them yourselves. So since we don't have much time, I'll just tell you the solutions right now for both problems, but then I want you guys to pause the video right now and then try solving them on your own before looking at my solutions. So for problem 93, the solution is going to be one blob. These three numbers are going to be in one blob, these three numbers and these three numbers. And for problem 94, the solution is going to be like this. And so, even though I just gave you guys the solution without much explanation, I do want you guys to pause the video and then come to the solution after you're done solving to really make sure that you guys understood this concept correctly. Now I'm going to go over problems starting from 95. And so our target number is 140. So I'm going to start by doing prime factorization. And so we can express 140 as 2 to the power of 2 times 5 times 7. And we know that multiplying 1 to any number basically gives a number itself, so multiplying 1 won't be too much of a deal. And so we're going to have two blobs, so it's going to look like this. So in this larger blob, we have 1 5, 1 7, and 2 2s. And we have 4 ones, but again, multiplying any number to 1 basically gives us the same result. So multiplying however many numbers of 1 would not have an effect. And in the other blob, we have 1 5, 1 7, and 2 2s multiplied, so that fulfills our requirements. So that factor blob puzzle is solved. And for problem 96, we have target number 24. So we can do prime factorization. And so we have 2 to the power of 3. 24 equals 2 to the power of 3 times 3. And so we need 3 2's involved and 1 3 involved in one blob. Again, these ones won't have an effect because multiplying 1 to any number gives the number itself during multiplication. And so, and the 4 here, each 4 is basically 2 times 2, so it's 2 to the power of 2. And so considering that, we're going to group these into one blob. So that's going to be one blob. We have 3 2's and 1 3. And then we're also going to group these three numbers together. So again, we have 3 2's and 1 3. And then we're going to group these 4 numbers together. We have 3 2's and 1 3. Now for problem 97, the target number is quite big. So we're still going to do prime factorization. And since it ends with the 0, we know that we can divide 900 by 10. Again, this can be expressed as 10 times 9, 5 2 3 3. So 900 can be written as 2 to the power of 2 times 3 to the power of 2 times 5 to the power of 2. And 25 is 5 times 5. So we can really write out the numbers so that we don't get confused. 9 is 3 times 3, 4 is 2 times 2, 10 is 2 times 5, 6 is 2 times 3, 15 is 3 times 5, 75 is 5 times 5 times 3, 12 is 2 times 3 times 2, and 30 is 3 times 2 times 5. And so now we've expressed everything in terms of prime numbers that are involved in the prime factorization of 900. And so for problem 97, we're going to group these three numbers into one blob. So there's two fives, there's two twos, two threes, and two fives involved. And then we're going to group these three into one blob. Again, there's two twos involved, two threes involved, and two fives involved. And then we're going to group these two numbers together. We have two twos involved, two twos involved, two threes involved, and two fives involved. Then for these, we also have two twos involved, two threes involved, and two fives involved. And so we have 4 blobs in total. For problem 98, our target number is 99. And so we can express that as 9 times 11. So we can express 99 as 3 to the power of 2 times 11. And so 33 can be expressed as 3 times 11. 9 is 3 times 3. And so we can group these two into one blob. So 1 11 and 2 threes. And we can group these 5 numbers together. Again, the 1 doesn't make a difference. So we have 2 threes multiplied and 1 11 multiplied. These two numbers can be in one blob. So 2 threes are being multiplied and 1 11 is being multiplied in one blob. And the same thing goes for these 3 numbers in one blob. Now for problem 99, we have target number 96. So we're going to do prime factorization. Since it ends with the 6, we know it's an even number and it's divisible by 2. So it's going to be 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2, 3. So 96 can be expressed as 2 to the power of 5 times 3. And we're going to write out the numbers inside the boxes in terms of the target numbers. So this is going to be 2 to the power of 3 times 3, since it's 8 times 3. 2 to the power of 2, 2 times 3, 2 to the power of 4, 2 times 3, 2 to the power of 4, 2 to the power of 4, 2 times 3, 2 to the power of 2. So once we've done expressing that in terms of prime numbers, we need to multiply 5 2's and 1 3. And so these two can be grouped into 1, since that can result in 2 being multiplied 5 times and 3 being multiplied once. This is also the same logic, since it's 2 to the power of 4 times 2 times 3. That translates to 2 to the power of 5 times 3. And then these two can be grouped together so that 2 is multiplied 5 times and 3 is multiplied once. And then these 3 can be grouped into one blob and these 3 into one blob. Now for problem 100, we have target number 72. So it ends with a 2, so it's divisible by 2. 36, the sum is 9, so it's divisible by 9. So 72 can be written as 2 to the power of 3 times 3 to the power of 2. And so all the 6's are going to be expressed as 2 times 3. And 18 can be expressed as 3 to the power of 2 times 2. And so these 3 can be grouped into one blob, so that 3 is multiplied twice and 2 is multiplied 3 times. These 3 can be grouped into one blob, so that 3 is multiplied twice and 2 is multiplied 3 times. And then these 3 can be in one blob, so 2 is multiplied 3 times, 3 is multiplied twice. And the same goes for this blob with 3 numbers. And so that's it for our factor blob puzzles. And I hope you guys have tried problems 93 and 94 before checking the solutions. Now we're going to talk about something called a pyramid descent. And so in a pyramid descent puzzle, the goal is to find a path of touching squares, one per row from the top to the bottom of the pyramid. And the product of the numbers on the path must equal the target number written on the top. And so for example, the product of the numbers on the path must equal to 140. And so we're going to do prime factorization of 140. And so since it ends with a 10, we know that it's divisible by 10. It ends with a 0, so it's divisible by 10. And so we can express 140 as 2 to the power of 2 times 5 times 7. And then similar to the blob puzzle, we're going to express large numbers in terms of prime numbers. So that can be expressed as 5 times 7, 5 times 2, 7 times 2. And so now we look for a path of squares that include exactly 2 2s, 1 5, and 1 7. And so a path would be the goal is to find a path of touching squares from top to bottom. So it's probably going to look diagonal. Well, it doesn't have to look diagonal. It can also look like this. It just has to be touching from top to bottom. And so again, 1 never makes a difference because as I said before, multiplying a number to 1 basically gives the number itself. And so we need to include 2 2s. So if we took that path, all the squares are currently touching. So we already have we already used up 2 2s. So this requirement is fulfilled. We also used a 5. So that requirement is fulfilled. So we only need to get to 7. But then it's impossible for us to go from here to here because the squares aren't touching. So that is not a path. Then another way to find this is we can just go straight down like so. Then, but then the problem with that is that 7 is used twice and 2 is used only once, so that would be incorrect. And then the path that would work then would be like this, where we use 5 once, 7 once, and 2 twice. And so we'll try solving some pyramid descent puzzles. So for problem 101, again, we're going to start by doing prime factorization of 36. So since 3 plus 6 is 9, it's divisible by 9. So we can write 36 as 2 to the power of 2 times 3 to the power of 2. And so a path must cross 2 twice and 3 twice. And so we can take this path where 2 is involved twice and 3 is involved twice. For problem 102, we're going to do prime factorization of 24. So we can express that as 2 to the power of 3 times 3. So a path must go through 2 3 times and 3 once. Again, the 1 doesn't have an effect because it's multiplication. And we know that a 4 is 2 times 2. And so a path that we can take is this way. So because of the 4, we use 2 3 times and we use 3 once. And so that is the path that we're going to take. For problem 103, we have target number 84. And so since it ends with an even number, we know it's divisible by 2. Same thing, divisible by 2. And so we can express 84 as 2 to the power of 2 times 3 times 7. So our path must go through 2 twice, 3 once, and 7 once. And we know that 6 is 2 times 3. And so if we go through this path, we use 2 twice because of the 2 and the 6. So we use 2 twice, 7 once, and 3 once. For problem 104, we have target number 120. Since it ends with a 0, we know it involves a 10, and it's divisible by 10. So we're going to break it down into 10 times 12. 10 can be further broken down into 2 times 5, and 12 into 2 times 6. And 6 can be broken down into 2 times 3. And so 120 can be expressed as 2 to the power of 3 times 3 times 5. So our path must go through 2 3 times, 3 once, and 5 once. And we know that numbers like 6 can be expressed as 2 times 3, and 10 is 2 times 5. And so using that information, we start with 2. So now, since we start by using 1 2, we only need to find 2 other 2's, and 1 3 and 1 5. And so we can use this path. So we use 2 3 times because there's 1 2 and 10, so that we're using 2 3 times, and then we're using 1 5, and we're using 1 3. Now moving on to problem 105, we have target number 180. And so 180, after doing prime factorization, we can express that as 2 to the power of 2 times 3 to the power of 2 times 5. So our path must go through 2 twice, 3 twice, and 5 once. And numbers like 15 can be expressed as 5 times 3, 10 expressed as 2 times 5, 6 expressed as 2 times 3. And so using that information, we start with 2, and we can take this pathway. So we use 2 2 times, 3 2 times, and 5 once. For 216, since the sum is 9, it's divisible by 9. So we're going to break 216 down into 9 times 24. And then break 24 into 12 and 2. So we have 216 equals 2 to the power of 3 times 3 to the power of 3. And so our pathway must cross 2 3 times and 3 3 times. And so 6 can be written as 2 times 3, 9, 3 times 3, 12 can be written as 2 times 3 times 2, and so on. And so based on that information, the path that we should take would be this path. And so we go over to 3 times and also use 3 times as well. Now we're on the last page, and so we have some more pyramid descent puzzles to solve. So I want you guys to solve problem 210 on your own before you check my solution. And so I'll just give you guys the solution right away, but make sure you solve this problem before. So pause the video, solve it yourselves, and then try to check your answer with the solution that I'm going to be giving you guys right now. So the solution for this would be taking this path. And I'm not going to give you explanation, but I want you guys to really try this problem yourselves and really understand how to solve these pyramid descent puzzles. For problem 108, I'm going to go back to explaining the solution. So 999 can be divided by 3. And so that's divisible by 9 because the sum of the digits is 9. So we can express that as 37. So what we have here is 999 equals 3 to the power of 3 times 37. And so that means that we must either use one of the 3 37s here. And then 9 can be expressed as 3 times 3. 27 is 3 times 3 times 3. And so the path that we should take is this path, where we use 3 twice and 37 once. For problem 109, we have 72. So doing prime factorization, we can express 72 as 2 to the power of 3 times 3 to the power of 2. And so 6 can be expressed as 2 times 3, and 4 can be expressed as 2 times 2. And so for 109, the path that we should take it's a little more complicated because more numbers are involved and the pyramid got bigger. But still, this is the pathway we should take because this path involves multiplying 2 3 times and multiplying 3 2 times. For problem 110, we have target number 400. Which can be written as 2 to the power of 4 times 5 to the power of 2. We're going to write 10 as 2 times 5 and 8 as 2 times 4. And so based on this information, the pathway that we should take is this. And so this pathway basically multiplies 2 4 times and 5 2 times. For problem 111, we have 1,485 as our target number. And the sum of the digits is 18, so that means it's divisible by 9. And so when 1,485 is divided by 9, we get 165, right? So going back to division, which we learned in the previous video, we get 165. And then 9 can be further divided into 3 and 3. 165 ends with the 5, so we know it's divisible by 5, and that would give us 31. That would give us 33. 33 can be further divided into 3 times 1. 3 times 11, 3 times 11. So eventually we can express 1,485 into 3 to the power of 3 times 5 times 11. And so we can express 55 as 5 times 11, 27, 3 to the power of 3, and so on. And so the pathway that we should take to go through 3 times, 5 once, and 11 once is this pathway. And so we multiply 3, 1, 2, 3 times, multiply 5 one time, and multiply 11 one time. So this is our last question of this video. We have target number 720. So that's 72 times 10. 72 can be further divided into 9 and 8. So it's divided into 3, 3, 2, 4. So we can express 720 as 2 to the power of 4 times 3 to the power of 2 times 5. And so the pathway that we should take to go over 2 4 times, 3 2 times, and 5 once is this pathway. So in this case, we go through 2 4 times. So once here, second time, and this is 2 times 2, so third and fourth time. And for 3, we go over it twice. And for 5, we go over 5 once. So that is the end of our video today, and I'll see you guys all in our next video. Bye!